Few would expect that in the heart of the Pacific Ocean exists a country where mountains, highlands, and volcanic islands rise and overlap like a world detached from ordinary reality. Here, ancient rice terraces cling tightly to mountain slopes, dormant volcanoes rest within crater lakes, and naturally sculpted rock formations appear as if they are testing the limits of human imagination. Mist-hidden mountain villages, volcano peaks shaped with almost impossible perfection, and sheer limestone islands together create landscapes where the boundary between geography and myth begins to dissolve. Each island and every mountain range carries its own imprint of time, climate, and belief, where nature is not only seen but experienced through layered terrain and elevation. And in this journey, we enter the unreal mountain worlds of the Philippines, where beauty needs no exaggeration, because it already surpasses what familiar human perception can believe to be real. El Nido Bacuit Bay. Located at the northern end of Palawan in the Philippines, El Nido Bacuit Bay is a coastal karst system where steep limestone towers rise directly from shallow, clear water. The landscape developed from uplifted limestone shaped by long-term marine erosion and rainfall. Vertical cliffs enclose sheltered lagoons and calm inner bays formed by selective rock dissolution. Shallow seabeds allow fine sediment to settle, maintaining high water clarity. Complex rock geometry reduces wave energy inside the bay. As a result, El Nido Bacuit Bay demonstrates how coastal karst processes create enclosed marine landscapes with distinct structure. Banawa Rice Terraces. Located on steep mountain slopes in northern Philippines, the Banawi Rice Terraces form a large-scale agricultural landscape built entirely by hand using traditional techniques. The terraces follow natural contour lines, creating stepped fields that control water flow and reduce soil loss. An irrigation network channels water from higher forested areas and distributes it evenly across each level. Stone and compacted earth walls reinforce the terraces against prolonged rainfall. The system reflects precise knowledge of terrain, water management, and soil stability. As a result, the Banawi rice terraces demonstrate how human engineering can sustainably reshape mountainous environments. Taal Volcano Island. Located within a large volcanic lake in the Philippines, Taal Volcano Island is a rare complex volcano where multiple vents and crater lakes coexist in a confined area. The island is built from layered basaltic lava, ash, and explosive deposits accumulated through repeated eruptive phases. A central crater lake reflects direct interaction between magma, groundwater, and surface water. Explosive eruptions are commonly driven by magma-water contact, producing ash plumes and pressure waves. Erosion channels, ash layers, and solidified lava surfaces record long-term volcanic activity. As a result, Taal Volcano Island stands as a clear example of high-energy volcanism concentrated within a compact landform. Chocolate Hills. Chocolate Hills in the Philippines is one of the world's most distinctive geological formations, spread across hundreds of square kilometers. More than 1,200 cone-shaped hills rise from the landscape, each averaging about 164 feet in height, composed mainly of limestone with a thin layer of soil. During the dry season, the green grass turns brown, giving the hills the appearance of countless giant chocolates placed side by side, which is how the site earned its name. Scientists believe that millions of years of weathering and erosion created this rare terrain, making Chocolate Hills a striking example of natural forces at work. From above, the hills extend endlessly like rolling waves, forming a natural panorama with no human intervention. Beyond being a tourist attraction, Chocolate Hills holds geological value, offering insights into the Earth's processes and the geological history of Southeast Asia. Mount Mayon. Located in the central region of Luzon in the Philippines, Mount Mayon is an active stratovolcano recognized for its near-perfect conical form and well-defined structure. The summit rises to approximately 8,080 feet, producing strong elevation-driven variation in temperature, wind, and precipitation. Alternating layers of basaltic and andesitic lava with volcanic ash record repeated eruptive cycles. Frequent volcanic activity maintains steep slopes by continuously renewing surface material. As a result, Mount Mayon stands as a clear example of an active stratovolcano with highly visible geological processes. Siquijor. Formed as an isolated limestone island in the central Philippines, Siquijor displays a clear transition between low coastal terrain and gently elevated interior highlands. Raised limestone terraces and narrow coastal plains define much of the shoreline. The geological foundation consists mainly of limestone and ancient marine sediments shaped by slow uplift and erosion. Rainwater infiltrates rapidly through porous rock, favoring underground drainage over surface rivers. Forest cover across the interior stabilizes soils and limits surface erosion. As a result, Sikijor illustrates how limestone geology and tropical climate create a compact and balanced island landscape. Zamboanga. Functioning as a west-facing peninsula of Mindanao, Zamboanga is a region where coastal terrain and interior mountains connect within a relatively compact area. Narrow coastal plains transition rapidly into mid-elevation mountain slopes. Volcanic, sedimentary, and metamorphic rocks record a complex tectonic foundation. High rainfall sustains short but steep river systems, transporting sediment toward the coast. Extensive forest cover stabilizes slopes and moderates surface runoff. As a result, Zamboanga illustrates how peninsular structure, mountain relief, and tropical climate shape an integrated coastal landscape. Mount Maculo. Located in southern Batangas in the Philippines, Mount Maculot is a limestone mountain defined by steep slopes and sharply cut rock faces. The summit reaches approximately 3,107 feet, creating noticeable variation in wind exposure and temperature compared to nearby lowlands. Fractured and weathered limestone forms narrow ridges and exposed cliff surfaces. rainwater rapidly infiltrates rock fissures, limiting surface runoff and promoting long-term dissolution. As a result, Mount Maculot demonstrates how tropical limestone terrain evolves through erosion and structural control. Sagada Mountain Village. Located in the highlands of northern Philippines, Sagada Mountain Village is a mountain settlement shaped by steep limestone terrain and narrow valleys. The village layout follows the natural slopes, with homes, paths, and terraces adapted directly to the landform. Weathered limestone surfaces create cliffs and rugged ground that expose ongoing erosion processes. Agriculture relies on thin soils and naturally guided water flow across terraced fields. Cool temperatures and high humidity influence vegetation patterns across the landscape. As a result, Sagada Mountain Village demonstrates how human settlement can function in close balance with mountainous geology. Camiguin. Formed by prolonged volcanic activity, Camiguin is a compact island whose landscape clearly reflects its tectonic origin in the southern Philippines. Steep volcanic slopes, short valleys, and a continuous coastline combine into a tightly integrated landform. Lava flows, ash layers, and solidified eruptive material create the island's geological foundation. High rainfall and steep gradients accelerate weathering and surface runoff, exposing rock structure. Dense vegetation stabilizes volcanic soils and regulates water movement. As a result, Camiguin demonstrates how small volcanic islands maintain structural balance under active climatic and geological forces. Surigao del Sur. Shaped by a Pacific-facing coastline and continuous interior highlands, Surigao del Sur is a geographically diverse province in eastern Mindanao, Philippines. Narrow coastal plains transition quickly into river valleys and mid-elevation mountain terrain. Sedimentary, metamorphic, and ancient volcanic rocks reflect a complex tectonic history. High annual rainfall sustains dense river networks that transport sediment from uplands to the coast. Extensive forest cover stabilizes slopes and moderates erosion. As a result, Surigao del Sur demonstrates how coastal exposure, mountain structure, and climate interact to form a balanced regional landscape. Leyte, shaped by monsoon circulation and surrounding seas, Leyte is a central Philippine island where mountains, coastal plains, and active river systems coexist within a compact landmass. The interior is dominated by low to mid-elevation mountain ranges formed through gradual uplift and long-term erosion. High annual rainfall sustains strong river flow that transfers sediment from uplands to coastal lowlands. Sedimentary and ancient volcanic rocks create a deeply weathered geological foundation with dynamic soil movement. Coastal plains develop along the shoreline through ongoing sediment deposition balanced by marine processes. As a result, Leyte demonstrates how inland topography and coastal systems integrate to form a continuous tropical island landscape. Mount Guiting. Located on Sibuyan Island in the Philippines, Mount Guiting is a rugged mountain massif defined by sharp ridgelines and steep, continuous slopes. The summit reaches approximately 6,752 feet, producing strong climatic and ecological variation over short distances. Volcanic and metamorphic rocks form the geological core, heavily uplifted and eroded. High annual rainfall accelerates erosion and exposes rock structure. Dense forest cover follows the terrain without obscuring its overall form. As a result, Mount Guiting demonstrates how tectonic uplift and humid climate shape sharply defined mountain landscapes. Mount Apo. Located on the island of Mindanao in southern Philippines, Mount Apo is the highest mountain in the country and a massive high-elevation landform. The summit rises to approximately 9,695 feet, creating strong altitude-driven variation in temperature, rainfall, and vegetation zones. Mount Apo is a dormant complex volcanic system built from layered lava flows, ash, and volcanic rock. As a result, Mount Apo illustrates how ancient volcanic structure and elevation shape large-scale mountain landscapes. Mount Tabayok. Located in the Cordillera Range of northern Philippines, Mount Tabayok is a high-elevation mountain forming part of Luzon's interior upland system. The summit rises to approximately 9,324 feet, producing clear altitude-driven variation in temperature and precipitation. Metamorphic and ancient volcanic rocks provide a stable geological foundation shaped by long-term uplift and weathering. Broad, continuous slopes allow rainfall to disperse evenly, supporting stable surface drainage. As a result, Mount Tabayok demonstrates how elevation, geology, and climate combine to form a coherent high mountain landscape. Iligan. Positioned between inland plateaus and the open sea of Mindanao, Iligan is a city where rivers, elevated terrain, and coastline form a continuous landscape system. The interior is characterized by low plateaus and gently sloping hills developed on weathered volcanic and sedimentary rock. Short but steep river systems transport water and sediment directly toward the coast. High annual rainfall sustains constant surface runoff and stable erosion processes. Coastal zones occupy lower terrain and remain directly influenced by wave and tidal action. As a result, Iligan demonstrates how upland terrain, river flow, and marine conditions integrate within a tropical urban setting. Mount Daraitan. Located on the eastern flank of the Sierra Madre Range in the Philippines, Mount Daraitan is a limestone mountain defined by well-developed karst terrain. The summit rises to approximately 2,425 feet, producing noticeable variation in temperature and moisture with elevation. Long-term dissolution of limestone has created rugged slopes, exposed rock surfaces, and surface drainage channels. As a result, Mount Daraitan demonstrates how tropical karst landscapes evolve under persistent humidity and erosion. Mount Halcon. Located on Mindoro Island in the Philippines, Mount Halcon is a steep, high-elevation mountain defined by deeply dissected ridges and narrow valleys. The summit rises to approximately 8,488 feet, creating strong variation in temperature and rainfall with altitude. Metamorphic and ancient volcanic rocks form the structural core shaped by long-term uplift and weathering. As a result, Mount Halcon illustrates how elevation, climate, and rock structure combine to produce a sharply defined mountain landscape. Mount Pulag. Located in the Cordillera Range of northern Philippines, Mount Pulag is the highest mountain on Luzon and a prominent high-elevation landform. The summit reaches approximately 9,600 feet, producing strong variation in temperature and moisture with altitude. The mountain is underlain by metamorphic and ancient volcanic rock shaped by long-term weathering. Broad upper slopes experience persistent wind and frequent cloud cover that influence surface conditions. Rainfall and fog provide continuous moisture that stabilizes soils. As a result, Mount Pulag demonstrates how elevation and climate interact to form coherent high mountain landscapes. Mount Batulao. Located in southern Luzon in the Philippines, Mount Batulao is a low-elevation mountain characterized by sharp ridgelines and short, steep slopes. The summit rises to approximately 2,661 feet, producing noticeable changes in wind exposure and surface temperature. Weathered volcanic rock forms the core structure, marked by fractures and angular surfaces. As a result, Mount Batulao demonstrates how volcanic geology and erosion shape a compact yet sharply defined mountain landscape. Mount Malapunyo. Located in southern Luzon in the Philippines, Mount Malapunyo is an ancient volcanic massif that forms a natural boundary between surrounding highlands and lowland plains. The summit rises to approximately 3,287 feet, creating noticeable variation in temperature, rainfall, and vegetation with elevation. As a result, Mount Malapunyo illustrates the long-term stabilization of an old volcanic landscape shaped by climate and erosion. Mount Gulugod Baboy. Located along the coastal region of Luzon in the Philippines, Mount Gulugod Baboy is a low-elevation hill system defined by smooth rolling ridges and open terrain. Seasonal rainfall and coastal airflow maintain gentle but persistent landscape modification. Grassland cover dominates due to stable drainage and limited forest development. As a result, Mount Gulugod Beyboy illustrates how low-relief terrain can develop clear geomorphological identity under tropical coastal conditions. Mount Kitanglad. Located in northern Mindanao in the Philippines, Mount Kitanglad is a major high-elevation mountain forming part of the island's interior upland system. Broad, gentle slopes allow rainfall to disperse evenly, supporting stable surface drainage. As a result, Mount Kitanglad demonstrates how elevation, geology, and climate combine to form a coherent, high mountain landscape. Mount Makiling. Located on Luzon Island in the Philippines, Mount Makiling is a dormant stratovolcano characterized by forested slopes and a well-preserved volcanic structure. The mountain formed through repeated lava flows and eruptive deposits that built broad ridges and gentle inclines. Residual geothermal activity appears as warm ground and hot springs, indicating remaining subsurface heat. Heavy tropical rainfall accelerates weathering and promotes dense vegetation cover. Short streams descending from the slopes regulate drainage and sediment transport. As a result, Mount Makiling illustrates the transition from active volcanism to a stable, tropical mountain landscape. Mount Dulang Dulang. Located in central Mindanao in the Philippines, Mount Dulang Dulang is a major high-elevation mountain forming part of the island's stable interior highlands. The summit rises to approximately 9,646 feet, producing clear altitude-driven variation in temperature and precipitation. Ancient volcanic and metamorphic rocks provide a durable geological foundation shaped by long-term uplift and weathering. Cool and humid highland conditions maintain dense forest cover that protects the terrain. As a result, Mount Dulang Dulang demonstrates how elevation, geology, and climate combine to form a coherent high mountain landscape. Mount Pinatubo. Located on Luzon Island in the Philippines, Mount Pinatubo is a stratovolcano whose recent activity dramatically reshaped the surrounding landscape. The present structure is defined by a broad caldera formed after summit collapse following rapid magma evacuation. Rainfall and surface runoff later filled the basin, creating a crater lake within the caldera. Surrounding slopes expose thick ash layers and volcanic deposits that record successive eruptive stages. Volcanic mud flows redistributed sediment across valleys and altered natural drainage systems. As a result, Mount Pinatubo clearly demonstrates how volcanic activity can rapidly reorganize terrain and hydrology. Mount Kalatungan. Located in central Mindanao in the Philippines, Mount Kalatungan is a major high-elevation mountain forming part of the island's interior upland system. The summit rises to approximately 9,462 feet, creating clear altitude-driven variation in temperature and rainfall. Ancient volcanic and metamorphic rocks form a stable geological foundation shaped by long-term uplift and weathering. As a result, Mount Kalatungan demonstrates how elevation, geology, and climate combine to form a resilient mountain landscape. Samar. Shaped by monsoon winds and heavy rainfall, Samar is a large Philippine island where rugged terrain, dense rainforest, and extensive river networks dominate the landscape. The interior consists mainly of low to mid-elevation hills and narrow valleys formed through slow tectonic uplift and prolonged erosion. High annual precipitation sustains continuous forest cover and active surface drainage across the island. Sedimentary and ancient volcanic rocks create a deeply weathered geological base with thick but erosion-prone soils. The coastline is highly indented, marked by cliffs, river mouths, and coastal zones exposed to the open ocean. As a result, Samar demonstrates how climate, topography, and geology integrate to shape a coherent tropical island system. Mayon Volcano. Rising as a near-perfectly symmetrical cone above the lowlands of southeastern Luzon, Mayon Volcano is an active stratovolcano with exceptionally clear structural definition. The summit reaches approximately 8,080 feet, producing strong altitude-controlled variation in wind, temperature, and rainfall. Alternating layers of basaltic and andesitic lava with volcanic ash record repeated eruptive cycles. Frequent eruptions maintain steep slopes by continuously renewing surface material. Solidified lava flows, ash deposits, and erosion channels reveal ongoing interaction between construction and weathering. As a result, Mayon Volcano stands as a clear example of an active stratovolcano with highly visible geological processes.